All right, tonight we're going to be doing Chapter 6, Section 3 and 4, which is on solving with elimination and then special solutions. So elimination is a little bit different than substitution because, as you can see, neither of these equations has like a letter that is alone that you can easily solve for. So instead, we're going to line them up and we're going to eliminate one letter. And in this case, we would eliminate this through addition. So if we literally add the top to the bottom, negative 3x plus 4x is 1x. This cancels out, and then we get negative 4 plus 10, which is 6. So x equals 6. And then you pick which equation looks more enjoyable to work with. I'm going to pick the bottom one. So 4 times 6 plus 2y equals 10. Therefore, y is negative 7. So the ordered pair point where they cross is at 6, negative 7. Now, we could take that 6 and also plug it into the top one just to make sure we did it right, to make sure we're getting the same answer. So if we do that, we're going to plug a 6 in for x. This is just rechecking ourselves. So we've got negative 18. And if you add 18 and then divide by negative 2, it does give us the same answer. So for sure, that's our ordered pair solution. So we've solved by graphing, we've solved by substitution, and then this section is about elimination. The sum of two numbers is 27. And their difference is 5. Now, we could solve this by graphing or by substitution, but elimination is actually the easiest because if we add these two, the y's cancel. So we get 2x equals 32, which means that x equals 16. Now, what's kind of unique about this is that we can take those same two equations, and instead of adding, if we subtract them, the x's will cancel. So I'm going to subtract them now. So x minus x is nothing. Y minus negative y is 2y. And 27 minus 5 is 22. So y is 11. So our ordered pair solution for these two is 16 and 11. And let's just check. Is 16 plus 11 27? Yep. Is 16 minus 11 5? Yep. So hooray. All right. This one isn't so beautifully set up to eliminate, but we can pick to multiply one equation or the other by a number, or both, to make it eliminate. So you see how this is 60? If I multiply this top equation by 2, I'm going to get a 60 next to my n, and then I can eliminate through subtraction. In fact, if I multiply by a negative 2, I could eliminate through addition. So I'm going to do that. Negative 150p plus negative 60n equals negative 80. Every single thing needs to be multiplied by that negative 2. And then we'll just rewrite the bottom one as it initially was. So now we're going to eliminate through addition. If you decided to multiply through by a positive, you would eliminate through subtraction. But addition is what makes this cancel. So we would have negative 100p equaling negative 45. And then I'm going to grab a calculator. Well, actually, I guess you don't even need to, because we're only dividing by 100. So I'm back. And I lost my negative on my 45 because that's negative. All right, so when we divide by 100, that just means you move the decimal 2 to the left. So our answer is positive 0.45. So we're going to plug that in for P. It doesn't matter which one you plug it into. So 50 times 0.45. I'll just do that real quick. Plus 60n is 35. And then if you subtract 22.5, you're going to get 60n equaling 12.5. And then if you divide by 60, you get 0.2083 repeating. Now this is some odd numbers, so I'm going to plug it in and make sure it works. I plugged it in to get the n to this equation, so I'm going to test this top equation. Because those numbers are a little bit weird. So I'm going to put 0.45 in for P and 0.2083 repeating in for N. And 30 times 0.2083 repeating is 6.25. 75 times 0.45 is 33.75, so it does check out. That's our right answer. 0.45 and 0.2083. Repeating. All right, next we're going to see that we can't just multiply the top. We have to multiply both. Okay, so I'm going to look at my x's. I'm going to make them both a 10. So I'm going to multiply this by 5 and this by 2. So that's 10x plus 15y equaling 25. And the bottom gives us 10x plus 8y equaling 32. So this time I need to subtract because I didn't multiply by a negative. So 15 minus 8 is 7. And 25 minus 32 is negative 7. So y is negative 1. Now you can plug negative 1 in. Let's go ahead and do that, and then we'll do what it says down here also. So 2x plus 3 times negative 1 is 5. So you would add 3. So x is 4. Now the bottom part says to solve by eliminating y for x. So I would make both of these 12. I multiply this one by 4 because this has a 4, and I multiply this by 3 because of that 3. So we would get 8x plus 12y equaling 20. And down here, 15x, multiply by a negative this time, plus negative 12y equals negative 48. So this time I'm going to add to eliminate because that's what gets that gone. So negative 7x is negative 28, and that gives me 4. So I know I did it right. So our ordered pair solution is 4, negative 1. Isn't it great how you can check your work? All right. We're going to use elimination twice. So first, we're going to put the first two together. I'm going to rewrite this. And then I'm going to put my x first and my z last. So I just flipped these two so that they would line up. Alright, so through adding, the y's will eliminate. So I get 3x plus 3z equals 21. Now I have another thing with an x and a z. So I can bring that 3z back through subtraction. And I can write that equation as 4x minus 3z equaling 7. And now I can eliminate through addition. Getting 7x equals 28, so x is 4. Now that I know x, I can plug it right here and solve for z. So 16 equals 3z plus 7. Subtract 7. So 9 equals 3z. So z equals 3. And now that I know x and z, I can pick one of these to plug it into to solve for y. So my x is 4 and my z is 3. So I have 8 plus y plus 3 equals 13. So 11 plus y is 13. So y would have to be 2. Now I can write this solution as my x value, then my y value, then my z value. And then the second part of tonight's homework is on solving the special equations. So this first one has one solution. It's two lines with different slopes. So there's one solution right here. The second one has all solutions because they are the same exact line lying on top of each other. And the third one are parallel lines with no solution. So this is the same slope, different y-intercept. And these are different slopes. The first one is. And this is the same slope, same y-intercept. Alright, so if something has no solutions, it's called inconsistent. And if something has solutions, it's called consistent. And then you either go to independent or dependent. So this first one, okay, this is not working for me, would be consistent, and then, because it has a solution, and then it's independent because it only has one solution. The second one would be consistent because it has a solution, and then it would be dependent because every single one is the same. And the last one would be inconsistent because there are no solutions. So parallel lines are inconsistent. The same line, which is also called coincident lines, are consistent and dependent. And intersecting lines are consistent and independent. So if you want to kind of look at these and see what they are, we don't need to necessarily solve them. But I think it's easiest to put it in y equals. So this top thing is simplified as y equals 3x plus 2. And this bottom one, we would need to subtract 3x from both sides. So negative y is negative 3x. I'm going to actually bring the 2 over also. Minus 2. So positive y is positive 3x plus 2. So this is the same line. So do you remember what that's called? If you go back here, same line is called coincident, or consistent and dependent. Okay, the next one, let's again solve for y. So I'm just going to add y over here. It's actually the easiest way to solve for y. So 3 plus x equals y. So then if I rewrite this with my y on the left, and then in mx plus b form, it's like that. So this is the same slope, different y-intercept. These are parallel lines. Parallel lines have no solutions. No solutions is inconsistent. And the last one, again, let's solve for y. So this is y equals negative 2x plus 7. This first one is 3x plus 2. These are two lines that are going to cross somewhere. So they are consistent because they have a solution. And independent because they only have one solution. So hopefully that works for you tonight, and I'll see you guys tomorrow. Bye-bye.